just so that we're clear, today we are dealing with isosceles triangles. How many know what an isosceles triangle is? All secret agents, take your earbuds out, please. Okay. Yes, how many know what an isosceles triangle is? Tell your neighbor quickly what an isosceles triangle is.
It's a triangle that has two congruent sides.
Okay, can I get a volunteer to tell me what an isosceles triangle is? Carson? Two sides congruent. What else do we know about an isosceles triangle? Logan? It could be acute, it could be right, but it could be acute, or excuse me, it could be right, it could be obtuse. Okay, it could be any of those actually. Anything else we know? Yes? Okay, so we know two sides are the same and two angles are the same. You're going to see in some of these theorems and corollaries today some of those statements being brought up. So really quick, we're going to spend about 5 minutes. You guys get going on your notes, get a good start, and then we'll start discussing it as a class. I know you may not be done with everything, but get to a place where you kind of stop here. Follow along. All right. Picture of a triangle to define. So isosceles triangle. These right here, an isosceles triangle that are congruent every time are called, what are those called? Uh-oh. Dude. What are these things called?
Oh, the legs.
These are called legs, okay? All right. What's that? Yeah, we've got the legs, okay? These right here that are also congruent in an isosceles triangle are called?
Base angles.
Good, base angles, not to be confused with space angles. They're distant cousins from faraway galaxies, okay? Base angles, all right? And then this guy is a
Vertex angle.
vertex angle, all right. All right, just so we have some different things that we can reference there. So there we've got it. Okay. Our theorems. Theorem 4.1. Some of these are pretty obvious, especially after what we found out we knew. But an isosceles triangle theorem, it actually has a name to it, so you could use that name in a proof later if you wanted. You don't want to use the name theorem 4.1, but isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if A is congruent to B, then angle A and angle B are also congruent. Okay, that's something we said that I think Cameron said was one of our deals there that we knew. Theorem 4.2, the bisector of the vertex angle of an isosceles triangle is a perpendicular bisector of the base. So if I have this triangle, this theorem states that if I take and cut my vertex angle in half, that means that's congruent to that, and we're in an isosceles triangle, then that bisector is going to intersect the base at a right angle, and it's going to cut that side in half. So AD is congruent to DB there. Okay, and I guess I'd actually need to have two markings here versus one, so because it's not necessarily congruent to that side. Okay, so another theorem there. All right, and theorem 4.3 says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. That actually says the converse. If you think back to yesterday's assignment where we had the if-then statements, we had the isosceles triangle theorem here. If two angles of two sides of a triangle are congruent, then the angles opposite those are congruent. Well, the converse to that says if two angles of a triangle are congruent, then the sides opposite those are congruent. So if the conditional and the converse are true, go ahead and tell your neighbor what other statement you could say. Say that statement to him. You have the answer? All right, go ahead. Yeah, well, if the conditional and converse are true, what could we say?
Well, I was thinking a guess, but we could say that AC is not congruent to BC if angle A is not congruent to
No, we're not going to use the negation of it. Just try to quick review of yesterday. Zach, what do you think?
I wasn't here yesterday.
Oh, you weren't? Oh, dude, did you watch the video last night? It's a good video, man. Probably up for an Oscar or something. Yeah. Yeah. Yes?
If two...
Oh, go ahead.
Me?
Sure, we'll let you go.
Oh.
We'll substitute now.
If two angles of a triangle are congruent, if and only if the sides opposite the angles are congruent.
So very close. Okay. We'll get rid of the first if. You got it though. Two sides of a triangle are congruent if and only if
That one.
the opposite sides are also congruent. Okay? Two angles. Okay?
So small.
The two sides of a triangle are congruent if and only if the angles opposite those sides are congruent. Okay. How many can remember the biconditional? It was a long time ago yesterday. I know. All right. We want to remember those statements. They'll help us out as we progress. So if both the converse and the conditional are true, then we get the biconditional. Spent way too much time on that. Let's move on. Corollary. Corollary to our isosceles triangle theorem says if a triangle is equilateral, it's also equiangular. Now, why would they put equilateral triangles in with isosceles triangles? Emma? Okay, so you're dealing with congruent triangles, and an equilateral actually has two equal sides. Okay, is an equilateral an isosceles triangle?
Yes.
You sure? Justify to your neighbor why an equilateral triangle would be considered an isosceles triangle.
The 2 legs.
Okay, who says yes? Who says yes, an equilateral triangle is isosceles? Who says no, it's not? Okay. All right. Hey, an equilateral is isosceles. How come? Boy, there's someone that hasn't. Ethan, what do you got? Two sides are congruent. That's the only rule on an isosceles. Two sides are congruent. I appreciate those of you who are raising your hand every single time. I call on you every single time, except for then I wouldn't get everyone else too. But I appreciate you still raising your hand. So, equilateral is isosceles. Every isosceles equilateral? No, every isosceles is not equilateral. It has to have 3 sides to be equilateral. Okay? Yeah, it's like squares and rectangles, correct. Okay? Converse of isosceles, okay, we talk about the angles, okay? Triangle is equiangular, then it's also equilateral. Okay, so if we know the angles are congruent, we also know the sides are congruent, and vice versa. So that would be congruent to that, and that tells us that. Okay. How many are with me so far? All right, let's do some problems off our assignment. I'll get you that, but while I'm handing that out, I want you to take a look at these 2 problems. Numbers 1 and 4. Try to solve for x and y. Work with your groupies. Hey, volunteer number 1. Let's take a look. Find the values of x and y. Let's zoom in on that. Cool guy. Okay, Grace, what do you got? What's x?
X, I got 39.
39. Okay. Let's write that in. Now, I haven't checked that, but we're going to go with it. What's y? Chase? 90. How many of you found y before x? Okay, that kind of helps. How many found x before y? Okay, if you found y before x, right, this, you know that a bisector cuts this side in half at a right angle, so y is 90, very true. And then if I know that 90 plus, what's this? How do you know it's 51?
Because they're congruent.
Good. Base angles are congruent. Okay. So you could have went both ways, right? We could have said 51 plus whatever equals 180, 78, and then cut that 78 in half to get 39. Or you could go 90 plus 51 plus what is 180. In this case, 39. So these 3 have to add up to 180, so this has to be 39. So x equals 39er. Done. Any questions there? All right. Well, how about 4? Oh, let's get someone to ask it. Emily, what do you got? What's x?
X is 31.
31? Maggie, what'd you get for y?
31.
Oh, how do you know that?
Because they're congruent. Because it's a perpendicular bisector.
Good. Perpendicular bisector tells us that this angle has to be congruent to that. Very good. So both 31. 90, 59, and 31 make 180. Well done. Okay. Any questions? I'm about up to my time limit today in teaching. I try to put time limits on myself. You guys are doing a great job at participating. Grace?
I just have a question on number 5 on the example side. It's like, so I'm kind of confused on where the X.
Oh, that's a good call. Yeah, number 5, y goes right with this angle. X goes with this angle. Yeah. So let's make that clear on those that don't look as clear. Any others like that? Let's turn that over, just make sure. Y on this one is this angle. I haven't told you your assignment yet, but I can't remember what we're doing yet. I'll double check. But okay, I think that's it. Maybe down here. X is this angle. Okay. Thank you. Good point. Why don't you take a look at number 7, 8er, and 9er. Okay? Work with your groupies. Example 2. Volunteer. Someone that hasn't participated yet today. So new. Julian. CF. So AF corresponds to CF. Julian, how do you know that? You're right. Very good job. How do you know? You don't know how you know? You just know? Maggie?
Because,
Yeah, just congruent. Logan? Oh, you think? Okay, we'll give you a redemption.
Because angle BAD and DCD are concurrent, so isosceles
Very good.
congruent.
Good, because those angles are congruent. A is congruent to C, therefore AF has to be congruent to CF. Yes. How about CD? What's CD congruent to? Rory? CD to BD, yeah. And how do you know that, Rory?
Because those two base angles are congruent.
Good. This angle is congruent to that angle. All right. CBD is congruent to angle C. And BE, B is congruent to, so who do it? Blake.
AE,
AE, yeah. Because
because the base angles are congruent.
their base angles are congruent. Very good. All right. So you'd want to make sure you put those explanations why, right? So explain, hey, angle A is congruent to angle ABE. Here it's okay to say angle A. So we could say angle A is congruent to angle. Here we'd have to say ABE because B could be a bunch of different angles. But here A is only that one. So angle A to angle AB. Nice. Honestly. Yeah. Nice job. Diamond got it. All right. Some of you didn't get the honest Abe joke. That was one of my best ones. Yeah. Yeah, Logan.
For number like 8 and 9 and CD and BA also work
For 8 and 9, so let's see. A, what'd you say? C what?
CD.
CD?
CD. B.
CB. No, CB wouldn't work. We don't know that this angle is congruent to that one. Yeah, CB would not work. 10-4?
Okay, that makes
All right. There's another one of my jokes. Come on, man. You guys are missing out on them all. Grace.
Wow, so if we, for the explain, if we just said like the isosceles triangle here.
I'd like you to say the angles there. Yeah. Yeah, state the angles. So for your AF, say angle A is congruent to angle F. Or angle, C. Okay. Good. Then obviously you have to put one there. Any other questions there? All right. Last one I want to do together. Number 13. Everyone take a look at it. 13er. Go with. Okay, Maddie, you're going to explain this one to me. I heard your amazing explanation, so this would be a really good one for you.
So I noticed that all the shapes were regular shapes. So both the squares had angles of 90, and the triangle had an angle of 60 because it was a equilateral triangle. And if you put them all together, it makes like a circle. So you add the 2 90s and a 60, which makes I think it's 240, and then you subtract 360, and then that's X.
Man, that's really good. Very, very good explanation. I hope that the mic picked all that up because that was awesome. I'm not even saying it. Well, I will. Okay, just in case it didn't. Yeah, these are all regular, like the vocab she used there. That's really good. So, regular meaning that's 90. That's going to be 90 then, and then this is going to be 60. 90, 90, and 60. What was that? 240 we said? 240 plus x equals 360. That makes an entire circle here. There's our x, and x then is 120. Excellent. Very good explanation. Hey, any questions there? Hey guys, great. Number 7 on the mixed. I'm not going to go through the whole problem with you, but what I do know is that this side and this side are what? They're congruent. So our setup then says x equals 2x minus 6. And from there we go through and solve. So just kind of picking that out from there. Good question. If you have any other questions, make sure you ask.